Hello students, you are welcome to today's class. In our last class, we talked about program development cycle. I would say programs are a set of instructions that tells the computer what to do. So today we are going to be looking at algorithms, those set of instructions, algorithm and flowcharts. And we said algorithms are a sequence of step-by-step procedure on how to solve a problem. So shortly, you're going to be watching a little video showing you on how algorithm and flowchart works. Please get your pen, get your notes, and I'll see you after the video. Thank you.
In our daily life, we receive some commands and give instructions to execute any work. It is no matter what kind of work, as soon as we get up in the morning or switch on the computer system, we only work as per instructions were given to us. Likewise, when your mother asks you to bring the vegetable from the market, does she simply ask you to bring the vegetables or give you detailed step-to-step instructions, something similar to this? Take the money from the purse, open the door, go to the market, look for the required vegetable procedure that's needed, go back home. It will be easier to find the file when detailed instructions are given. Giving detailed set of instructions is always important because it enables you to clear understanding of the motive, the process, and the interventions. Let's take an example. You want to buy a pencil from a local stationery shop. Here are the instructions. Go to the stationery shop, ask for the pencils. If the pencils are available, take them and make payment for the same. If not available, then check any other stationery shop. Return home. So detailed step-to-step instructions to perform a task is commonly known as algorithm. The algorithm can be properly written for the motive of performing a task with its objective and all the possible scenarios. A good algorithm must contain finite numbers of steps, no repetition of steps, desired solution to the problem, defined set of input and variables. Need for algorithm. You must be aware that the computer works smartly, but it is not able to do any work of its own. Computer needs instructions to carry out each task. For performing every task on the computer, you need to give well-defined step-by-step instructions, taking into account all the possible situations or the problem that might come up during the execution of the computer system. With the help of algorithm, we can create easy such detailed instructions. This is the reason why before developing a software, algorithm should be developed first. So algorithm helps the computer programmer to make a list of what instructions that must be given to the computer to perform any task. Example of an algorithm. Write an algorithm to prepare a cup of tea. Step 1. Put the tea bag in a cup. Step 2. Fill the kettle with water. Step 3. Boil the water in the kettle. Step 4. Pour some of the boiled water into the cup. Step 5. Add milk to the cup. Step 6. Add sugar to the cup. Step 7. Stir the tea. Step 8. Drink the tea. Write an algorithm to purchase a t-shirt up to $250 from a garment store. So get the money from the parent, go to a garment store, ask for the t-shirt of your size. If the t-shirt is available, ask for the price. If the price is less than or equal to $250, go to step 6, else go to step 9. Step 6, ask for the price. Step 7, give money to the owner of the shop. Step 8, take your t-shirt. Step 9, go home. Although real life examples are good to understand how an algorithm works, algorithms find the most commonly used in solving mathematics and computer programs. In terms of computer, algorithms are also defined as a step-to-step procedure to solve a problem. Write an algorithm to input username and say hello. Step 1, start. Step 2, ask for the name. Step 3, save the name and end variables. Step 4, display hello end. Step 5, stop. Let us learn some complex examples of algorithm. Write an algorithm to check the greatest number. Step 1, start. Step 2, enter two numbers, num1 and num2. Step 3, check if num1 is greater than num2. Go to step 4, else go to step 6. Step 4, display num1 is greater. Step 5, go to step 8. Step 6, display num2 is greater. Step 6, stop. Let us now complicate the same algorithm by adding a third number. Write an algorithm to enter 3 numbers and then print the largest number among the 3. Step 1, start. Step 2, enter the 3 numbers num1, num2 and num3. Step 3, check if num1 is greater than num2. Then go to step 4, else go to step 7. If num1 is greater than num2, go to step 5, else go to step 7. Step 5, display num1 is the largest. Step 4, go to step 11. Step 7, check if num2 is greater than num3. Go to step 8, else go to step 10. Step 8, display num2 is the largest. Step 9, go to step 11. Step 10, display num3 is the largest. And step 11, stop. The above steps are a bit complicated. Imagine the difficulty of reading even bigger problems. There's an easier form of respecting the same step-to-step procedures. This is whereby flowchart come into place. So we are going to be looking at what is the meaning of flowchart and how flowchart works. A flowchart is a grammatic representation of a sequence of logical steps of an algorithm. As we use English language to show the step-by-step procedure in the algorithm, flowchart can be displayed in simple shapes to the process and data flow in a computer program. The following display the symbols using flowchart. So these are the symbols used when designing a flowchart. We have the start or stop. It is used to begin and end a flowchart. We have the input. It is used to expect input or give output of a program. We have the process symbols. It is used for writing the process of instructions during calculations. We have the decision. It is used to check or apply to any condition in the program. We have the flow line. It can also be called the arrow line. Flow line shows the direction in which the controls of the program is moving. This arrow line are used to connect various symbols of the flowchart. So lastly, we have the on-page connector. It is used to connect one flowchart to another. So these are the symbols. So now let's take an example. Draw a flowchart to prepare a cup of tea. Start. Put the tea bag in the cup. Fill the kettle with water. Boil the water in the kettle. Put some of the boiled water into the cup. Add milk, sugar to the cup. Strain it in a cup and serve the hot tea. Then stop. Flowchart. Make a flowchart to input username and say hello. Example 2. Start. Take the name from the user. Message hello name. Then stop. Let's take another example. Make a flowchart to enter 2 numbers and to tell which number is the largest. So start. Enter num1 and num2. Display num1 is larger. If yes, is num1 greater than num2? If no, display num2 is larger. So let's take another example. Write an algorithm to enter 2 numbers and tell which of the number is the largest. So we have our stats. Enter num1 and num2. Is num1 greater than num2? If yes, num2 is greater than num3. If no, is num2 greater than num3? Then display num3 is larger. Num1 is the largest, num2 is the largest. Stop. So what you are doing, you are just comparing.
Welcome back. I hope you enjoyed the video. So who can tell me what is algorithm? You want to try? Okay, so we said algorithm are what? Step-by-step procedures in solving a problem. While flowcharts are pictorial representation of such algorithm. Please make use of the online portal, send in your questions, send in your contributions, and I'll see you in our next class. Bye.